This lecture is a short introduction to square roots. The square of a number is the number times itself. For example, the square of 5 is 25 because 5 times 5 gives us 25. We could say that the square of -5 is also 25 because -5 times -5 gives us positive 25. The reverse process of squaring is finding a square root. The square root of 25 is 5 because 5 times 5 is 25. And the square root of 25 is also -5 because -5 times -5 is equal to positive 25. Every positive number has two square roots, a positive and a negative. The positive square root is called the principal root. In this course, we will only be using the principal root. In later math courses, that negative will come back. I just wanted to show you it from the beginning so that you're not surprised about where that negative came from later in algebra course. We use this square root symbol here, called a radical sign, to indicate the positive square root of a non-negative number. The square root's defined as followed. The square root of a positive number a is the positive number b whose square is equal to a. So let's find some square roots. When finding the square root of 100, we want to ask ourselves, well, what number raised to the second power is equal to 100? 10 squared is equal to 100. That means then that the square root of 100 is equal to 10. The square root of 64. Again, we want to ask ourselves what number raised to the second power is equal to 64. 8 raised to the second power is 64. Therefore, the square root of 64 is 8. Let's take a look at some fractions. What number raised to the second power is equal to 1/4? That can be kind of tricky to figure out the fraction as a whole. So what you can do is you can look at the square root of the numerator separate from the square root of the denominator. So we can do the square root of 1 over the square root of 4. What number raised to the second power is equal to 1? 1. And what number raised to the second power is equal to 4? 2. So the square root of 1/4 is 1/2. Let's use that same technique of looking at the numerator and denominator separately. This is the same as the square root of 9 over the square root of 16. What number raised to the second power is equal to 9? 3. And what number raised to the second power is 16? 4. The square root of 9/16 is equal to 3/4. All these numbers that I've listed here for you, 1, 4, 9, 16, and so on, They're called perfect squares because their square root is a whole number or a nice fraction. Not all numbers are perfect squares. So we need to know how to use our calculator and how to plug it in. So if you don't have your calculator, pause the video, get your calculator, come back. So let's approximate these square roots using a calculator. We want to round to the nearest thousandth. Typing in the square root of 10, you should get 3.162. And the square root of 64, 7.874. Although it's very difficult to figure out exactly what a square root is without a calculator for the non-perfects, we should be able to determine between which two consecutive whole numbers a square root lies. If we go back to our list of perfect squares that I gave you up here, and I want to find the square root of 43. 43 falls right here in between 36 and 49. Well, I know that the square root of 36 is 6, and I know that the square root of 49 is 7. The square root of 43 is somewhere between the square root of 36 and the square root of 49. Therefore, when I actually take the square root of 43, it should be somewhere in between these two numbers. So the square root of 43 is between 6 and 7. Let's try another one of those. Let's figure out between which two whole numbers the square root of 123 lies. Taking a look at my list of perfects, just towards the end, we have 81, 100, 121, 144. 123 falls in between right here. We know that the square root of 121 is 11. The square root of 144 is 12. 123 falls in between those two numbers, therefore its square root should fall in between these two numbers. Square root of 123 is between 11 and 12. This is a great skill to have, especially as we start using our calculators and are maybe doing computations that are unfamiliar to us. We want to have an idea of whether our answer is reasonable or not, and this helps us to do that.